we can spend some time talking about ionic compounds now. Ionic compounds are the other type. Okay? Molecular compounds were nonmetals only. They were small groups of atoms that were bonded together. Okay? Ionic compounds are different. We've got positive and negative ions. Usually it's a metal and a nonmetal. Okay? In fact, if it's a compound with just two elements, for it to be ionic, we'll have a metal and a nonmetal. They've formed positive and negative ions. Okay? So we'll show that structure to you in just a second. But remember in the last chapter we talked about how metals form positive ions, nonmetals form negative ions. We were able to predict, for instance, that sodium, Na for sodium, forms the Na plus ion. Chlorine gains an electron to form the Cl minus ion, and as a result, right, these are the stable ions that they formed. The sodium atom with its plus charge, if it's next to the chlorine with its minus charge, they are attracted to each other because opposite charges attract. Okay? So what we've actually got up here, this is a view of what an actual compound like NaCl would look like. Well, it's going to have positive ions and negative ions. They're all going to be stacked up like this, and they're going to be alternating because opposite charges attract. Now, we have no NaCl molecule. It's totally different from water. Right? If I drew water, looks like that, and that's just a molecule. In a sample of water, we maybe have another water molecule and another water molecule, but they're totally independent of each other. In an ionic compound, all we have are alternating ions, and it's stacked up, and this pattern continues in all directions. Okay? So can you see how there are no individual ions? It's just opposite ions that are stacked together. That's just because this ion will be attracted to all the negative ions, so it's just negative ones that are touching it, and so on. There's no specific grouping. We can, however, say a formula unit would just be one of each for NaCl. But that formula unit is no different from this formula unit right there. See how that works? It's more just a repeating pattern as opposed to individual groupings. Okay? So the formula unit is what we would consider to be sort of the smallest individual part of an ionic compound, but really all it is alternating ions all stacked together like that. Okay? Now, the key part about forming an ionic compound is that the compound must be, so it's star by this, ionic compounds must be neutral overall. Okay? And by neutral, we mean the plus charges and the minus charges are all balanced. So in NaCl, you'll probably notice that for every one plus, I have a minus. And it goes plus, minus. And if we counted them all up, all of the pluses would equal all the minuses. That's our ionic compound. It's going to have no charge overall because it's going to have the same number of positive and negative ions. Okay? If we go to make a formula of a compound from calcium and chlorine, okay, first thing we have to do, identify it's an ionic compound because calcium is a metal, chlorine is a non-metal. Metal and a nonmetal will make an ionic compound. And because of that, first what we have to do is predict charges. The calcium ion forms, let's get a periodic table here. Right here, calcium is in group 2a, so it's going to have to lose 2 electrons. In fact, what's helpful for a lot of students is writing these charges, 1 plus, 2 plus, 3 plus for aluminum and gallium, and then going back, minus 2 minus, and 3 minus for those. That's what we talked about last time. So calcium will form a 2 plus ion. That's going to be key to what we're doing here. Okay. Chlorine, Cl, and again from the periodic table here, Cl minus, because it just needs to gain 1 electron to have the same number as argon. So, sorry, Cl minus. Okay. Now the thing is, we would not have a neutral compound if I had calcium ions and chloride ions just alternating 1 to 1 like that. See how that would work? If I had a calcium ion and a chloride ion, it would be plus charged. And that's not a neutral grouping of ions. So think about this. Which one of these do I actually need more of? These are the ions that we have to work with. Okay. Which one of these do I actually need more of? I need more of the one that has smaller charge to it. So we're not going to have a 1-to-1 ratio of these ions anymore like we did up above with sodium chloride. What ratio do we actually need? Determine ratio needed for a neutral compound. Well, calcium is 2 plus, chloride is minus. What we actually do, if those are the ions, we're going to swap those charges. To make ratio. In this case, calcium was 2 plus, chloride was 1 minus. We need a 1-to-2 ratio to be neutral. And what a 1-to-2 ratio means is that for every 1 calcium ion, I will have 2 chloride ions. Get it? 1-to-2. Okay, we need a 1-to-2 ratio to make a neutral compound. Let's write that, neutral compound. Because if you look at this group of ions, this is a neutral group. I've got a 2 plus here, and I've got 2 minuses there. Okay? That's a neutral grouping. So in order for this compound to be neutral, for every 1 calcium, I need 2 chloride ions. Okay? Step 3, formula comes from the ratio. It's just, in this case, CaCl2. The formula has listed out each of the elements. Okay. In order, we're going to go metal and non-metal. We'll talk about that on the next page here. But 1 calcium for every 2 chlorides. Notice there are no charges in this formula now because the compound is neutral overall. It's made up of individually charged ions, but overall there's no charge in this compound, in this formula overall. So that's why there are no charges listed.